Can I take UG NPTEL course for my MCA semester? So can you please tell me more about what exactly is in your MCA syllabus? After that, I can tell you this. Yeah, basically these NPTEL courses which are showing UG and PG it means that for example, if some course is undergraduate level, so basically you just need to have a basic knowledge of 12th class. However, if some course is your post graduation level, then you should have the knowledge of this graduation. For example, if you are taking some course on machine learning and it is post graduation level, then you should have done your graduation at least in computer science. So for your semester, if the courses are relevant, then it will help you in that. So you can take. Okay, so now I am starting. Is my screen visible? Anyone please
Yes,
confirm? Okay,
yes,
okay.
yes, ma'am.
Okay, thank you. Okay. So good evening everyone. I am Riya Takwal. I am doing my PhD. Please mute yourself. Yeah. So I am Riya Takwal. I am doing my PhD at IIT Kharagpur under the supervision of Professor Sudeep Mishra. Today I am here to discuss the topic which were discussed in your course Introduction to Internet of Things in the week 1, and after that I am also going to discuss some questions of the previous year assignments. So first of all, what exactly is this Internet of Things is? So basically in Internet of Things, this internet technology is used to interconnect various machines, tools and humans with each other. So it can be with the help of wireless technology. So there is one another definition. What is Internet of Things? So Internet of Things is a network of physical objects that contain embedded technology to communicate and sense or interact with their internal state or external environment. So with the help of these technologies, the physical objects can interact with each other as well as the external environment. So basically there are sensors embedded in these physical objects. These sensors are going to sense the environment, and accordingly the actuators which are present are going to respond. I'll define all those terminologies one by one in the later slides. After that, now the characteristics of Internet of Things. So first characteristic is it is efficient, scalable and associated architecture. So basically in Internet of Things there are millions of devices which are interconnected with each other, and since these interconnected devices are communicating with each other and making the life of the human easier, so this make the complete technology as efficient, and all the interconnected devices are associated with each other, so the architecture is associated. Second characteristic is unambiguous naming and addressing. So basically for all the devices which is present in your Internet of Things have particular names or addresses associated with them. For example, yeah.
No, sorry to interrupt. Is this session is recorded?
Yeah,
And
I'm recording this.
okay, thanks.
So I'll upload this on YouTube. You can also see there.
Yeah, thank you so much.
Yeah. Okay. So second characteristic is unambiguous naming and addressing. So in Internet of Things, every device is associated with a particular address, and with the help of that address, the exchange of messages or the communication between these devices can take place. So this is similar to your conventional networking only. So in case of your conventional networking, each device has particular IP address, and with the help of that IP address and MAC address, those devices are going to communicate with each other. So similarly here, some addressing is provided to these devices, and with the help of those addresses, the devices can interact with each other. The next point is abundance of sleeping nodes, mobile and non-IP devices. Further, so in IoT there are abundance of sleeping nodes. So what exactly is this sleeping node? So sleeping nodes are the nodes which are not active at a particular time. So whenever required, these devices get active, do their work, and whenever their work is done, they again go to the sleep mode. So there are lots of massive sleeping nodes present, mobile nodes which can move from one place to another, and non-IP devices. So basically there are some devices which do not have IP addresses associated with them. The next one is intermittent connectivity. So in IoT network, it is not always compulsory that all the devices are connected with each other regularly. So there might be a possibility that the connection is established between the two devices, and after that the connection is disconnected. So there is intermittent connectivity. Now the applications of IoT. So first application is smart parking. Basically your Internet of Things can be utilized in smart parking. So in parking lots we can deploy sensors, and with the help of those sensors we can detect whether there is a space in the parking area or not. So by deploying for example ultrasonic sensors in the parking area, this ultrasonic sensor will detect whether there is some space or not, or you can also deploy cameras. With the help of those cameras you can get to know whether there are space or not. So by using those kind of IoT devices, you can get to know whether there are space in parking areas or not. Second one is structural health. So what exactly is structural health? So structural health means in case of your industries, there are various machines. So in order to get to know about their health, there is a need of IoT devices which will detect whether those machines are working fine or not. So basically you can think of your vibration sensor, temperature sensor, or sound sensor. So you can deploy those sensors over the machine, and by getting their values, the values of those sensors, you can predict whether the health of the machine is in good state or not. For example, if your machine is getting 2 watt, it means it is not in good state, right? So with the help of those value, you can get to know whether your machine is going to be faulty or not. So before its downtime, you can prevent it from you can prevent that machine from getting faulty. Next one is noise urban maps. So your IoT devices can also be used for detecting the noise pollution in your urban cities. So by using the sound sensor, you can get to know that how much noise is getting produced or generated in a particular city, and on the basis of those data, you can analyze that what is the possible measures that should be taken in order to reduce that noise. The next is smartphone detection. So basically, with the help of various sensors and the technologies which is used by your IoT devices, for example your Bluetooth, Wi-Fi, you can detect whether a smartphone is present in a particular area or not. The next one is traffic congestion. So in your similar to your smart parking in your vehicular network, you can use IoT devices in order to get in order to know whether there is traffic on your roads or not. So basically you can use cameras in order to detect whether there is a traffic or not, or on the basis of that data you can decide the alternate route that you can follow. The next is your smart lighting. So smart lighting is nowadays very common in various institutes. So whenever some person moves into the room, the lights will automatically turn on. So basically some kind of sensors, for example your ultrasonic sensors are used. So ultrasonic sensor will get to know about the motion of the person, and on the basis of that motion the lights will turn on. Next one is your waste management. So for waste management also various kinds of IoT devices can be used. For example your cameras can be used near your dustbins. So whenever your dustbin is completely full, you can send alert to the management, so they can recycle that waste or they can empty those dustbin. Next one is smart roads. This is similar, this is only preventing the traffic congestion and related to smart parking only. Next one is your supply chain control. So basically in your industries, your manufacturing industries, there are various stakeholders involved from starting to the end process. For example, from the beginning of your raw material to the end point where your complete product is delivered to the customer. So in order to maintain the flow of the data from the raw material to the manufactured product, it is required that there is a complete track of product from starting to the end. So basically various kind of IoT devices, for example you can use RFID tags in order to track those products from starting to the end. So basically RFID tags are attached to every product which is sent in the supply chain, and with the help of those RFID tags you can get to know that where exactly your product is, where exactly this product has been reached, how much the production of that product is taken or not. So every this thing can be taken care with the help of your IoT devices. Next one is your smart grid. So in your smart grid, IoT devices can be used. Then tank level. So basically in order to know about the level of the tank, you can use a fluid sensor, it can detect the level of the tank. Then photovoltaic installations, after that water flow, then your stock calculation. All these are the application areas where you can use IoT devices by deploying the sensors, and once the sensor is deployed they will sense the environment and further take the necessary action according to the values which is sensed by the sensors. Now the IoT enablers. So basically, there are various enablers which can which are responsible for implementing IoT Internet of Things. So first one is RFID. I have already told you that by deploying RFID over the devices, you can track them. Then second one is nanotechnology, third is sensors, then fourth one is smart network. Here only four enablers are given. However, you can also say actuators are there. And after that, your AI technology, machine learning technology, all these things are the enablers of IoT. Now in this diagram, it is clear that this IoT can be deployed at your agriculture, at your healthcare, at your industries, and with the help of these communication technologies, these IoT devices can interact with each other. Now these are the enabling technologies here, with the help of which these IoT devices can be implemented over these industries. Now the difference between IoT and M2M. So what is this machine to machine communication, and how it is different from IoT? So basically, this machine to machine communication is related to the communication or interaction between the machines which are deployed in your industries. However, IoT is more, the bend of IoT is more toward the end users. So basically, in case of your IoT, your machine to machine interaction will be there. Apart from that, machine to human interaction will be there. So basically, this M2M is a subset of your IoT. So here it is written that M2M refers to the communication and interaction between the machines and the devices. Such interaction can occur by a cloud computing infrastructure. For example, devices exchange information through a cloud infrastructure. Further, your M2M offers the means for managing devices and device interaction while also collecting machine or sensor data. So basically, in case of your M2M, everything is related to your machines only. So there is no role of human in case of your M2M. However, in case of your IoT, the interaction between machine to machine will occur. Apart from that, the interaction between human and machines will also occur. Now, M2M is a term introduced by telecommunication service providers and pays emphasis on machine interaction by one or more telecom communication networks. Sorry. Now, M2M is a part of IoT. While M2M standards have prominent place in the IoT standard landscape. As I have already told you that M2M is a subset of IoT, so it is a part of IoT. However, IoT has a broader scope than M2M since it comprises of a broader range of interaction, including the interaction between devices, things and people, things and application, and people with applications. It also enables the composition of workflows comprising all of the above interaction. IoT includes the notion of internet connectivity, but is not necessarily focused on the use of telecom networks. So basically, in case of M2M, only telecom networks are associated. However, in case of IoT, it is not necessary that we use only telecom networks. There are various other technologies also which are used in your IoT network. Now, IoT network configuration. So basically, that how your IoT devices are interconnected with each other. So these diagrams are showing this. So first one is your IoT LAN. So basically, if your this is similar to your LAN only, so local area network. In case of local area network, the devices, if the devices or computers are connected in a smaller area, then it is called a local area network. So similarly, for your IoT LAN, if your IoT devices are interconnected, if the IoT devices of a smaller area are interconnected, then it will form your IoT LAN. Basically, in case of your IoT LAN, there might not be a use of gateway in order to combine or in order to connect these IoT devices. However, for your IoT WAN, where your IoT devices are spread over a large network or large area. These devices should be interconnected with each other with the help of gateway. Now third is your IoT proxy. So IoT proxy is a device between your IoT network and your internet. So this IoT proxy will help in managing this IoT network by managing the flow of messages between the internet and your IoT devices. Yeah. Now sensing, as I am saying that in case of your IoT network there are various sensors which are deployed, and these sensors are going to sense your environment. So what exactly is this sensing is? So sensor detects the changes in the ambient condition or in the state of another device or a system and forwards or processes this information in a certain manner. So basically this sensor is a device which is going to sense the conditions of your environment or the devices which are on which these sensors are deployed. And after that, once the sensing is done, either these sensors forward the data to some other device which will process the data, or they can process this information by their own also. They perform some input function by sensing or feeling the physical changes in the characteristics of system in response to a stimuli. For example, heat is converted into electrical signal in a temperature sensor, or atmospheric pressure is converted into electrical signal in a barometer. So basically whenever we need to transfer this data, for example, your temperature sensor is going to sense the temperature. So in order to transmit that temperature data or the heat which is sensed by the temperature sensor, it is converted into the electrical signal and then forwarded to the another device which will perform some processing on that data. Sorry. Now transducing. So transducer converts or transduce the energy from one kind to another. So in case of sensing, as I have told you that in order to transmit the data, we need to convert one form of energy into another form. So sensor is a type of transducer. So because sensors also convert the energy, one form of energy into another. For example, in sound system, a microphone converts the sound waves into electrical signal for amplifying. The next example is loudspeaker converts the electrical signal back into the sound wave. So these are the examples of your transducers. Further, your transducer is a collective term which is used for your sensor as well as for your actuators, because transducer is a device which only converts one form of energy to another. So it can be your sensor as well as your actuators. Now these are the figures of different types of sensors. For example, your pressure sensor, your ultrasonic distance sensor, analog temperature sensor, camera, this is Raspberry Pi camera sensor, infrared motion sensor. So these different types of sensors can be used in different applications according to your need. Now the classes of sensor. So based on the output value which is generated by the sensors are classified into two categories. First one is your analog sensor and second one is your digital sensor. So okay, I'll tell you the definition later. And based on the data type, the sensor are classified as your scalar as well as your vector sensor. Now first one is your analog sensor. So analog sensors are the sensor which produce the signals or the output values continuously, and the value is generally proportional to the quantity which
Hello,
is
ma'am.
yeah.
Ma'am, sorry to interrupt you. Ma'am, many students are waiting. Is it possible to join them?
Yeah, sure, wait.
Okay, ma'am. Thank you.
Please try to join before 6:02 or 6:03 because it will be difficult for me to get back here. Okay, so please everyone join before 6:02. Okay, someone is asking for Hindi, but I don't think that everyone understand Hindi. If everyone is fine, then I don't have any problem. I can also explain in Hindi.
No, no, better to continue in English only.
In English only, na?
Yes, yes.
Yeah. Okay, fine. Now I'm starting. Yeah. Okay.
Is there any option to automatically approve?
What?
Like
Can you
is there,
please repeat?
no, is there any option like to check like automatically you can admit the
No,
data?
there is not this option. Okay. Yeah, I was telling about the analog sensors. So analog sensors are the sensor which produce output which is in the continuous form, and that output is proportional to the value which is measured by your sensor. The example of your analog sensor is maybe your temperature sensor, speed, pressure, displacement, strain. All these quantities are continuous in nature, so the sensors of these quantities are mostly in analog form. However, your temperature sensor may be digital also. Now, for example, the temperature of a liquid can be measured using a thermometer or thermocouple, which continuously respond to the temperature changes as the liquid is heated up. So basically, the continuous change, if we are measuring the continuous change of a particular entity, then we are going to use these analog sensors. However, on the other hand, if your sensor is producing any discrete value, for example, any in the form of 0, 1, on, off, or any kind of discrete value, for example, only 97, 98, for example, your digital temperature sensor, nowadays digital thermometers are there which are producing values which are measuring your body temperature in the form of, they are producing discrete values and producing your temperature as 97.8 or 95, whatever. So these are your digital sensor. So digital signal only produce discrete values which may be output as a single bit or by combining these bits to produce a single byte. Now the scalar sensors. So scalar sensors produce output signal or voltage which is generally proportional to the magnitude of the quantity which is being measured. So this is the scalar value as we have read in in physics there are two types of quantities. First one is your scalar quantity and second one is your vector quantity. So scalar is only the magnitude, so the sensors which are only measuring the magnitude of a particular quantity are called your scalar sensor. Now the physical quantities such as your temperature, color, pressure, strain, all these are scalar quantities, right? So in order to measure these quantities, the sensors which are used are called your scalar sensor. Now the example is your temperature, because your temperature is only going to produce some value, right? There is no direction associated with that value. So basically your temperature sensor is your scalar sensor. Now on other hand, your vector sensor, so along with your magnitude, if sensors are also sensing the direction or the orientation of a particular quantity, then those sensors are called your vector sensor. The example of your vector sensor is accelerometer. So based on the orientation of your accelerometer, it is producing different values and generating different values with respect to your x, y and z axis. Now the deviations which can occur in your sensor's value. Okay, so first one is your offset error or biasness which can occur in your sensor value. So if your output signal differ from the correct value by a constant, then that variation is called your offset error or bias. For example, if the correct value is, for example, in a temperature sensor, if the correct value is 97 Fahrenheit, however your sensor is measuring it as 98 Fahrenheit, then your bias is 1. Then your okay, non-linearity. So non-linearity is a deviation of a sensor transfer function from the straight line to some other kind of function. So what is this transfer function? So transfer function is the relation between your input and the output of your sensor value. So if there is any deviation between this transfer function, then this is called your non-linearity. Okay. Third is, if the output signal slowly changes independent of the measured property, then this is called drift. So long-term drift over months or year is caused by physical changes in the sensor. So basically this is due to your sensor become faulty. So if okay, so it is not dependent on the value which is measured by your sensor. However, your sensor become faulty, so it is just because of that fault the value get added into your the value is measured by your sensor due to the fault. For example, your sensor is always measuring 100 degrees Celsius or whatever. So this is your drift. So it is not dependent on what exactly your sensor is measuring. So it always give a particular result. Now noise. Noise is a random deviation of a signal that varies in time. The last one is hysteresis error, which causes the sensor output value to vary depending upon the sensor previous input value. So this kind of error is dependent on the previous value of the sensor. Now the actuation. So okay, the first component main component of your IoT network is your sensor, which is going to sense the environment, and the second main component is your actuator. So based on the value which is sensed by your sensor, this actuator is going to perform some tasks. So actuator is a component of a machine or a system which moves or controls the mechanism of the system. So basically, whenever some value is sent by your sensor, so on the basis of that value, this actuator is going to perform some task. For example, consider an example of an industry where you have deployed a temperature sensor over a machine. So basically what is the aim is, so whenever this machine get heats up, then we need to switch off the machine. Okay, so we will deploy temperature sensor which will measure the heat of that particular machine. So if the temperature goes higher as compared to the threshold value which we have predefined, then the actuator will automatically turn off that machine. So actuator is a component which is responsible for controlling your machines or acting upon the values which are sent by your sensors. So after that, actuator is the mechanism by which a control system can act upon an environment. I have already told you this. An actuator requires a control signal and a source of energy. Yeah, so basically on the basis of this control signal, this is going to act upon that particular value, and there is a need of source of energy which is responsible for the working of this actuator. Now on receiving a control signal, the actuator respond by converting the energy into the mechanical motion. So basically I have told you that actuator is going to turn off your machine. So this for that this need to convert the energy into mechanical motion by turning off the machine. Now the different types of actuators which are available are hydraulic actuator, pneumatic actuator, electrical, thermal, mechanical. These are the different kinds of actuator. These are the pictures of different actuators. Okay, so basically for your assignments you can get a picture of a particular kind of actuator, and you have to guess that which actuator is this or which sensor is this. So basically you have to know that how different actuators and how different sensors look like. Now convergence of domains. So basically in your IoT technology, these various kinds of domains are converged in order to make the seamless interaction between your different devices. So this is not required yet. I'll discuss about this later. Now the components of your IoT. So first component is your device. So this is the end device or which interact with each other. Then the local network, so the network with the help of which these devices interact with each other. Then the internet, backend services which are required in order to make these devices to interact with each other, and the application through with the help of which we can access these devices. So these are the main components of your IoT network. So from this figure you can see the different components. So these are the things or the devices. So it can be anything else, your sensor, your actuators, all those things comes under your things or devices. Then the local network, and then internet, backend services, and there is also application with the help of which you can access the functionalities which is provided by the IoT. Now, yeah, the IoT. So, what are the different classification of the IoT components that are required? So, we required some component for the interaction and communication with other IoT devices. Then we need some components for processing and analysis of operation. There is a need of component for internet interaction. After that, we also need some components for handling the web services. Then there is a need of components to integrate the application services with the IoT. Then there should be a user interface to access the IoT. So this user interface should be user friendly, so that the end user can access the functionalities which is provided by your IoT. Now this is the service oriented architecture of your IoT. So basically there are 4 layers in this architecture. First one is your sensing layer. In sensing layer, your all sensors, RFID tags and actuators are there. After that, your network layer. So with the help of this layer, your sensing the devices which is present in the sensing layer can interact with each other. Further, the third layer is the service layer. So basically these devices need some services, right? So with the help of this layer, these devices get the services. And this is the interface layer. So basically your end users are going to interact with the IoT devices with the help of this interface layer. So this is the interface layer. Now the IoT gateways. So IoT gateways are the devices which are responsible for connecting your IoT devices with the external internet. So basically it is responsible for internet connectivity and IoT LAN intra-connectivity. Further, it is also responsible for upstream address prefixes are obtained with the help of your IoT gateways, and after that your LU addresses are also maintained with the help of your gateways. So basically the addressing of IoT devices are maintained by your gateways. Now the question, the previous run question, I am going to discuss the previous run question. So for that I'll ask question, and after that you will give me the answer and we'll discuss the solution of this. Okay. So first question is, which of the following is a static mechanism for address allocation of IoT nodes? Options are configuration over a management interface. Second option is IPv6 address based on hardware identifier. Third one is both configuration over management interface and based on hardware identifier. Fourth one is IoT nodes can't be configured statically. Anyone please? Anyone? Okay. Can anyone tell whether week 1 is completed or not? Week 1 assignment.
Answers are in chat box, ma'am.
Okay. So better will be to speak because I'm not able to see chat box. So what's
Yeah, ma'am.
up?
Few things we have completed.
What?
No, in first week assignment, few questions we have completed.
Okay. So these questions are also related to your assign, not related, but these questions are from your week 1 topics only. So please discuss here. So which of the following is a static mechanism for address allocation of IoT nodes? Which option is correct? Anyone please?
Option C, ma'am, both.
Okay, why?
It is because the hardware identifier, it will have MAC address, so it will not change. So it's static.
Yeah, right.
So
Yeah. Okay. So IoT nodes can be statically configured in different ways, such as an address can be configured over your management interface, or a node may use IPv6 addresses based on your identifier, hardware identifier. Next question is, which of the following error is commonly found in heating of metal strips? Anyone?
it is actually C, I think. C.
See, right. So this is the definition only, right?
Yeah.
Okay. Question number third. Identify the component which is given. So whether it is a gas sensor, PIR sensor, light sensor, or a speaker.
It's a PIR sensor.
Okay. So for what purpose PIR sensor is used?
Motion detector.
Yeah, right. Now, question number 4. X performs active application layer function between your IoT nodes and other identities. So, what exactly is this X? It is IoT node, IoT proxy, IoT gateway, IoT network.
It is actually C, gateway.
Gateway. It's IoT proxy, because IoT, I have told you the definition of IoT proxy, right? So, IoT proxy is responsible for the integration of your IoT nodes as well as the application layer or the internet. So basically this application layer is the internet.
Okay, ma'am. Thank you.
The next question is, which of the following field in IPv4 header format indicates that it is concerned with label transmission? Options are traffic class, hop limit, fragment offset, destination address. Anyone?
D destination address.
Destination address. How?
Because if it has a address onto which the packets have to be transmitted, then we can say that it is reliable.
But with the help of address, how can you say that it is liable only?
No, because I thought that it is having.
See, let's consider an example that you have to give a letter to a particular person, right? And you have his address, but in between that letter content get corrupted, or you miss that letter or something, so the transmission is not liable. Or if for example you have divided that message into various letters, and why somehow you lost one of that message in between in the path only, so how can you say you have the address, you reach at that particular address, but one of the message is lost, so how can you say that the transmission is liable only?
Okay.
Okay, so correct option for this is fragment offset, because if you remember of your computer networks course, then in that there is a fragment offset, and your message is divided into various smaller messages, and once for those messages fragment offsets are given, and if those fragment offsets are matching, then we can say that the the combination of all those small messages can form a complete message, right? It means there is no loss in between.
Okay, ma'am.
Okay, so fragment offset can tell whether the transmission is liable or not. Now question number 6, which of the following is the function of IoT gateway? Options are
D all of these.
all of these, right? So gateway is responsible for the interconnection between your IoT devices and your uh, other between your different IoT devices. So basically it will manage the flow of your messages, data forwarding, device management, protocol conversion, all those things are done by your IoT gateway. Now which of the following actuator convert pressure into force? Options are mechanical actuator, pneumatic actuator, electric actuator, and last one is your magnetic actuators.
It should be B, ma'am, pneumatic.
Right,
Actuators.
it is pneumatic. So pneumatic actuator enable large forces to be produced from relatively small pressure changes. Yeah. Question number 8 is, which of the following mechanism for address auto configuration provide more control on the allocated addresses? Option are DHCP v6, slack, both DHCP v6 and slack, and none of these.
It should be C, I think.
C, both.
Yeah.
Why?
Because I know
What?
DHCP is it will actually auto assign the IP address.
And what about slack?
Slack will also, I think, it will do the same functionality.
But
Okay.
here it is given as DHCP v6. This is a previous run. I need to check this question, because as far as I know slack is used for this. I'll check this
Okay.
question. Yeah. Now, which of the following can measure position? Options are potentiometer, encoder, both potentiometer and encoder, none of these.
It should be encoded.
It should be encoder, not potentiometer.
Yeah, because potentiometer is only for adjusting the resistance to increase or decrease the voltage, I think.
Both potentiometer and encoder can be used. So basically your
Okay.
potentiometer sensor measure the distance and displacement of an object, in a linear or rotary motion. So with the help of this, you can get the position also and your
Okay.
yeah. So question number 10, in a scenario when the IoT proxy has uplink connectivity, does the IoT LAN need global addressing mandatorily? Options are yes, no, not applicable. Anyone?
It requires that addressing, global addressing, because it will be accessing across the various networks, and so it should be having a globally addressable name, so that it can be accessible by all the so that it can be accessible across all the networks which are actually interconnected.
So correct option is no. So when the IoT proxy has uplink connectivity, it proxies communication between the local IoT nodes and the nodes in the external network. So in this scenario where all communication go through proxy, IoT LAN does not need global addressing, but can manage the with local link or ULA addresses depending upon the type of addressing. Okay. Next question is, which of the following is true? M2M is not a subset of IoT. WOT and IoT are same. IoT and M2M are same. Last one is none of these. Anyone please?
D.
D, right. Okay, so what is M2M? I have told you.
It's machine to machine.
Definition that I know, machine to machine.
Yeah, it is actually the interlink between the machines, which means they can speak with each other.
And what is Web of Things?
Web of things within, within a LAN, they can actually they can speak with each other within a LAN.
Okay, now question number 12. So basically two statements are given and you have to tell whether these statements are true or false. So first statement is aliasing errors occur if the input variable or added noise changes periodically at a frequency proportional to the multiple of the sampling rate. Second statement is if the signal is monitored digitally, the sampling frequency can cause a dynamic error triggering aliasing error. So okay, first option is both statement 1 and 2 are false. Second one is both statement 1 and 2 are true. Third one is statement 1 is false but statement 2 is true. Fourth one is statement 1 is true but statement 2 is false. Anyone? Okay. So here both the statements are true. Now question number 13. Does polymer based actuator find application in manufacturing artificial muscles? Options are yes or no. Anyone?
It's like AMR, yes.
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 Yes, that is right. So can you please give an example where you have seen such kind of deployment? No? Next question is unique local address are intended to allow routing over the network that expands over multiple links and routing hubs and even can expand over multiple networks. Can these addresses prevent address collision? Options are yes, no, not applicable.
Yes, ma'am.
Yeah, right. Now last question is, which of the following is an example of your vector sensor? Options are pressure sensor, strain sensor, both pressure and strain. Last one is your sound.
Both pressure and strain sensor.
Is an example of your vector high sound sensor. How your pressure and strain is going to detect your orientation or direction? Can you? Someone has given the answer as pressure and strain, right? In case of your pressure and strain, there is no direction or orientation associated. However, in case of your sound, we need to know that from which direction or which orientation your sound is coming. So it is necessary for a sound sensor to be a vector sensor. Okay.
But I believe pressure, we know the pressure is coming from upward direction or downward direction or east or west. Why this direction is not associated with the pressure at least?
See, in case of your pressure sensor, how pressure is applied on, for example, your sensor is placed right, and on that if some quantity is placed, then you can, that is only in one direction, right? How your pressure sensor is work. For example, I'll show you the figure.
See, it needs some contact, so there is no need of some direction.
I understood, like if the pressure sensor is kept on the top of the tank, it will just measure the pressure from the top of the tank. That's it.
What can you please repeat?
Yeah, if the sensor is placed somewhere in the tank, and it need to give you the pressure of the water, and as the water goes up, the pressure gets built up.
See, for that you cannot use pressure sensor. There are different sensors which are called liquid sensor. So in that application you have to use those. So pressure sensors are something like that, where you have to put pressure on this point and it will detect the amount or magnitude of the pressure which is applied.
Okay, so direction is irrelevant here.
Yeah, direction is irrelevant in case of your pressure sensor.
Thanks, madam.
Now, we have around 1 hour more. So, if you have any queries or if you want me to discuss something in the next lecture, any question, please?
Actually, as we go ahead in the session, we will develop many more questions.
Yeah.
This is just the start of the session, so.
Yeah. But actually, we have to do 2-hour sessions, right? So that's why. So 1 hour is for doing assignment and this thing, and 1 for doubt clearance. That's why.
So whatever you discussed, so these are all last year assignment questions.
Yeah, these are the last one assignment questions.
Excuse me, ma'am. You can explain how Zigbee works over that protocol 805 and
These will come in the further lectures actually. So that time I'll discuss those things.
Okay.
Yeah. So for today's lecture, if there is some doubt or in the questions, or if there is some topic related to your week 1 which you want me to discuss, then I can discuss right now, or I'll discuss in the next lecture also. So if there is something like that, then we can related to the projects that we can do with the help of IoT or anything. Can we have live sensor experiments done? You mean in these live sessions here? No, here we are only for discussing your assignment questions, not for your these experiments or projects. Here we are going to discuss about your assignment questions only.
Excuse me, ma'am, is it possible to explain how the automatic address assignment happens to the devices?
Automatic what? Automatic
Uh,
address.
yeah,
Can you
yeah.
please
How it that automatic address assignment?
uh, automatic address assignment to your IoT devices?
Yes, ma'am.
Yeah. So basically, with your gateways are going to utilize your protocols, which are your DHCP V6 and your Slack, and with the help of those protocols, this assignment is done. Can you suggest some books for introductory part of as I'm okay? So books are already given. This I'll write that. So Introduction to Internet of Things is the name of the book which you can follow. Can we get this PPT for reference studies? I'll upload the video over the YouTube, so you will not get the PPT, but you can download the video and have the content of the PPT.
The same way we get email notification after uploading video to YouTube.
That thing I don't know, because this handling part is done by NPTEL only, so this thing I don't know.
But where can exactly we get this video then on YouTube? Is there any in NPT channel?
You can search for Riya Tapwal. I'll write the name, or in the next lecture I'll share the link of this video. This will be better, I guess.
Yeah, that would be better, ma'am. Otherwise, I mean, it is difficult to find on YouTube. If at all, directly if you are getting, that's fine. Otherwise,
Yeah.
So introduction of the IoT, are you going to get any PDF book or I didn't understood what you replied?
For the book, so yeah, the name of the book is the Introduction to Internet of Things.
So the book we are going to get as a link from you?
No, you have to purchase that. It is available on Amazon, I guess. Yeah.
Okay.
Yeah.
Thank you.
Any other question? Can you do experiments on Tinkercad showing how to code for sensors? Basically, coding part of the sensor will be done in the later part of these lecture series, and that time we can try this. Okay, so no other questions. Should I stop here? Do we have any Raspberry Pi programs run on? Yeah, later on in this lecture series, you will get some Raspberry Pis and your Arduino programs, so that time you can learn about these. What are the other IoT devices will be introduced? So for this course, actually you will only get to know about some sensors and Arduino and Raspberry Pis only. Can it be helpful in doing projects? Yeah, it will be helpful. You can do programming over Raspberry Pis and interconnect your different IoT devices with the help of Pis and get them controlled by them. So yeah, it will be helpful. Any suggestions for projects? So which kind of project, UG level projects you are talking about, or in which field? For example, in manufacturing, healthcare, agriculture, there are various domains actually in which you can do UG level. Okay, so for example, if for agriculture domain if you are talking about, so you can develop some project which is going to detect whether the moisture level for your crop is appropriate or not. What are the scopes in research? Wait, I'll answer one by one. So I was talking about the agriculture project. So you can develop some project, IoT based project, where you can detect the moisture level for your crop, whether it is appropriate or not. You can use a humidity sensor for that. If the level of humidity is soil moisture sensor, humidity sensor you can use. So with the help of humidity sensor you can get to know whether the moisture level is appropriate or not. Further, you can use cameras in your fields in order to detect the motion done by your kettles, in order to prevent your crops from different kettles and different kind of intruders. These are this is the project which is applicable in the agriculture domain. Similarly, for healthcare domain, you can develop some project which is going to detect the heart rate. You can use different sensors which is going to detect the heart rate, temperature of a patient, and based on those value the alerts can be sent to doctor or some caretaker, and on the basis of that the real time monitoring of the patients can be done. So these types of projects are available. And after that, what are the scopes in the research? So basically for IoT scope, you can develop your own sensors, plug and play sensors. After that you can develop sensors which are not consuming much energy. So thinking of that side, you can use IoT. Now, do we need assignment bits in final exam? This thing I cannot tell you. Soil moisture sensor, how the tunneling through the gateway is initiated and what are its requirement and application. This thing I need to check. I'll write down. Can you please give us some idea about final this thing I cannot do. Someone has written next class. What do you mean by this next class? Okay. Do you have any nano sensor introduced? In this lecture series, no nano sensors were introduced, but for this, if you want, then I can read some content and let you know in further slides. Ma'am, can you mention some national competition in which we can showcase our device? This thing I don't know. Do we have no advanced IoT course available? I guess this is the only course available for your IoT. Some day-to-day life IoT project ideas. Yeah, this agriculture domain, I have told you that you can use different cameras in your fields in order to detect whether kettles are going into your fields or not. Second is your automatic lights you can use. So basically on the basis of your motion into the room, your lights will get turned on, and whenever you will get out of the room, your lights or your fan will get turned off. So these kinds of projects are available which you can use in your day-to-day life. Will the next class assignment be based on today's lecture? No, this is related to your first week topics. Whatever is taught in your first week, this is related to that only. How to choose better sensor according to the situation. Can you please elaborate what exactly do you mean by better sensor? Ma'am, could you explain the impact of mobility on addresses? That how there is no impact of mobility on the addresses basically. So this thing is maintained by your gateway. So whenever if your IoT move from one network to another network, then only actually these prefixes are provided by gateways to your IoT devices. So whenever your device move from one network to another network, there is no change in the main address will not change, however the prefix will change. So basically there is no impact of mobility on the address. Can you mention some national competition? For this you can explore Manthan. Actually there is one site, Manthan, which is run by government of India, where you can show your projects and your proposal which you are going to generate. You can show such kind of projects there. Could you explain? The vector sensor is a sensor that detects the translation power in 3 directions. Okay, so what you want to, Sandeep, what you want to ask here? Next session we are going to discuss about next week work. Not next week work, but week 2, whatever was taught in week 2, I am going to provide you a summary of that, and after that the assignment question of the previous run of week 2, I am going to discuss that. Yeah, every week have sessions on the assignment of the previous run.
Are we going to conduct the same way like 6 to 8 every week?
Yeah, on Friday 6 to 8.
Okay, thanks.
But from next week try to join before 6:2 or 6:3, because it will be difficult for me to admit you all here once I started. IoT is quite new to me, so it's taking bit time to grasp the thing. Any suggestion for the approach? Just look the videos which are already there over the NPTEL, and whatever you find difficult, you can ask me here the questions related to your doubts.
What happens, madam? We are working people.
Yeah.
So 6 o'clock our office is closed, and 6 o'clock we start the meeting. So it takes half an hour, 45 minutes to travel, and then we log in. So we are sorry for being late. I'm very sorry for being late.
Yeah, that is not in my hand actually. This time slot is provided by NPTEL only, so I have to start.
I truly appreciate that, but please let us in even if we are late. That was the only request.
Sure.
Thank you so much.
Any other question? the last date for submission of week 1 and week 2 is 8. Do we have uh, problem session for week 2 before that? No, it will be on next Friday only. This is pre-decided time. I cannot help with that. The deadline for could you please explain what the week 0 assignment is? Is it the prerequisite? This is week 0 is just a run that yeah, this, you can consider it as a prerequisite. How many hours of NPTEL exam will be there on April 30? These questions you can ask on your that discussion forum because these things are not handled by me, so I don't have any idea. Related to your exam, you can ask over your discussion forum. Any other question? Can we talk directly to the presenter? Presenter means who? The professor who was conducting this IoT course. This thing I don't know because I'm also uh, this you can contact him by using his mail ID, or you can ask this question over your discussion forum. No, week 0 is not graded. Offline. Uh, online. So you want him to yeah, there are two live sessions also, so he will you can interact with him on those live sessions. So basically for this run there will be two live sessions. You will get the notification regarding this, and on that day you can interact with him directly. Does this course include any specific case study on successful IoT device? By this we will get a vague idea about how to develop and make according market standards. No, basically this course is related to develop some basic idea about the IoT. However, there are various devices with the help of which you can get an idea. And yeah, there is in the upcoming series you will get to know that how to use these IoT devices. You will get to know about the programming, how to integrate different IoT devices and make product. Okay, what projects you have done in the field of IoT under your BTech time? This is personal question, so why do you want to know that which projects I have done? Ma'am, could you suggest any research ideas on IoT? Yeah, basically in case of IoT you can okay, for making the IoT devices more smarter, deploying machine learning algorithm over the IoT devices, you can do that, because IoT devices are the resource constrained devices and deploying machine learning algorithm is difficult over them. So how to deploy or how to build some lightweight machine learning model over these devices, this could be the research topic you can explore. Yeah, okay. So for BTech level student, okay, I can give you the example. For example, I have given you, I have already given you agriculture example. Then you can also build some smart band which can detect the health of the patient. Further, you can develop some smart helmet kind of thing which can be used in mining industry, because your worker which goes into mines, they get to have various problems, such as they have to face different kind of they have to face different kind of gases. So with the help of smart helmets, you can detect the different gases through which these workers get exposure. So all those things you can develop for so basically, depending upon the domain, that which domain you are going to deploy your project, you can develop some small IoT device or IoT sensor by integrating different IoT sensors. Okay, so one example I can give you is few days back, I have developed a bed sheet which is used to monitor uh, which is used to monitor the health of the patient which are affected by COVID. So basically, what I have done in that is I have deployed sensors into the bed sheet, and based on the pressure which is exerted by the patient over the bed sheet, I am going to detect whether the condition of the patient is good or not. So basically, what happened is, what I have done in that work is on the see, whenever a patient is in normal health condition or a person is in normal health condition, then the movement which is done by him over the bed sheet is a particular there is a particular okay, you can see a particular change in the data, right? But whenever a patient is ill or a person is ill, he make unusual movement over the bed sheet. So based on the movements which is made by the person over the bed sheet and the pressure which is exerted by the patient over the bed sheet, I am going to analyze the data in that particular project, and on the basis of that data, it is detected whether that patient is in good health condition or not. And if that patient is not in good health condition, then alerts were sent to the caretaker directly. So something like that you can do. What type of data is detected by you to study? Data is related to the pressure sensor only. I have used pressure sensor, and the data which is generated by that sensor only, I have analyzed that data and used machine learning model in order to analyze the data, and on the basis of that, I have the model has decided whether the patient is in good state or not. So similar kind of things you can also do. This is just an example. You can use IoT in various other fields also. Publish subscriber communication model. This topic will be covered in, I guess, third or fourth week. So that time we will discuss about this. So basically, in case of your publish and subscriber communication model, there is one device which is going to publish the task, and further the subscriber is going to use that particular task for that application. Which is the best servicing technology for IoT? Azure, AWS, Google Cloud. You can use any servicing technology, because it's just a Depending upon the requirement, the pricing policies, you can use any one of these. So it is not decided that which is the best technology. So it's up to you whether you want to use Azure, AWS and Google Cloud. Yeah, it's fine. You can ask project's idea here. So basically, the best suitable project for you is to develop some agriculture-based project where you can deploy some camera, or you can deploy some sensors with the help of which you can detect the movement of cattle, or you can also develop some smart management, smart waste management system where you can deploy camera or sensor in your dustbins, and with the help of that you can detect whether your dustbin is full or not. So this dustbin, smart dustbin idea, you can only do that at your home. Also, you don't need to go anywhere. So these kind of small projects you can deploy. What can be a good source for searching a specific sensor according to our need? Means a source that is used by you as you have experience. A source means you have to you want to purchase that sensor, or you just want to read about that sensor. What? Yes, purchase. Okay, so you can use robu.in, robu.in. So there you can get all types of sensors. Or I'll write. So here you will get different kinds of sensor, Raspberry Pis, Arduino, all those IoT related devices you can get here. You can use camera in that case. Raspberry Pi camera you can use. Basically in this you have to do image processing. So whatever the picture is taken by your camera, whether your dustbin is full or not, so you have to do some analysis on that. You have to use a machine learning model, and based on that it will be decided whether your dustbin is full or not. And once it is done, then you have to send alerts to the management that dustbin is full, or some SMS kind of thing you have to do. Alerts are not sent by using sensor. You have to use communication technology. Later in this lecture series I'll tell you that which kinds of communication technologies are used in order to send the alerts between different IoT devices and all those things. Any other question? Best components available in the market mean? for purchase. No, this course will not tell you this. Machine learning, right? Uh, for what you are, Shushant, what you are asking machine learning, right? Can you please elaborate? In case of dustbin is full or not, yeah, you have to use machine learning model in order to do the this image processing thing. So for that you have to use machine learning model. Whether the NPTEL exam, these questions are you can ask over discussion forum. Any other question related to project or related to the topic which we have covered today? If not, then I am closing the session. Thank you.
Thank you, ma'am.
Thank you,
Which
ma'am.
programming language will be best for the further use in IoT? Uh, you can use, okay, for over Raspberry Pi. In order to control, you can use Python. I have joined late. Is there any possibility to get any recording of it? Yeah, I'll upload this video over YouTube, so you can get from there. Okay.